Hey, this is Sam Ritchie. I've just finished writing the first Road to Reality executable essay, and I wanted to show what it feels like to write one of these things in this environment that I've cooked up. So on the left side, we have my text editor. This happens to be Emacs, but it could be anything. You could use VS Code or text editor or whatever you want. And on the right, we have the rendered version of this essay that Clerk, the notebook system, generates. So over here, the way I've set this up, if I change anything, like I add some exclamation points and save, the notebook environment will update, or the rendered version will update on save. I can add more text, and while I'm typing, nothing updates. But when I save, look at that. Now, what's nice about this environment, and what I've extended it to do is, let's look down here. We can embed code and images and math and things like this, even simulations inside of the system. So this simulation here is defined with this block of code here. This is kind of a dirty secret of this first essay. This is not, it's not a very nice way of writing an animation like this. What we like is something where we say, take a scene, put a donut in it, put a particle in the donut, flick the particle, extend an arrow. And it would be nice, where we'll get to, is that you can just add each of those things one at a time and compositionally build up a scene. I'll show an example of that in a second, because I know how to do that now. That was the big breakthrough that let me write this. What we can do, though, is I can change the code on the left, and the simulation will live update. Here I'm changing the initial conditions. I'm changing the speed that the that the particle fires off at. So here, if I give it a little more boost in the up direction, you get this sort of shape. Just to verify, if I say, let's go a little lower, it stays on the outside. But there's really beautiful behaviors you can get out of these geodesics, as they're called. I'll actually show a demo of what that could look like. Here's a piece that Colin Smith put together, which is a similar donut with a particle on it, except we have this control panel here, which lets us mess with the radii of this torus or donut. And we can also change the angle. Oh, of course, did I break it right away? We can also change the angle that we fire the initial particle at around the donut. Sorry, just had to reboot that page. Yeah, this lets us take over and live change the angle that we send this thing off. So instead of watching it evolve. And you get these really beautiful resonances that this particle can fall into. Like here, it sort of stays on this one track, which I find very surprising. As we mess with the donut, all these behaviors come up that are really powerful and are not obvious from the equations. So that's the idea, is that you can build scenes like this as part of your writing, and then just go back to your prose and not stress. Here's the one I had broken. Let's close that. So yeah, we've got the math, we've got the torus. Down here, if we look down below, Clerk by default will take Clojure source forms and run them. Any form that it sees inside the file, it will execute, and then the output will be stuffed below in the rendered output. What this project is all about is extending the system to teach Clerk how to talk about math and plots and animations and things like this, so that we can talk about physics systems and have those systems perform themselves inside of the browser. Here I've got this system, I've got this form here, which is saying I want to add x to theta, and EMI, the computer algebra system backing this, just outputs a mathematical expression. I don't know if it's a good choice. Here I'm having it render as math. What we could do is call freeze. Behind the scenes, it's really just a list in the Clojure programming language of plus x theta. But by default, just to make it look pretty, I'm saying anytime you print something, go ahead and if it looks like this, run it through and make it look like math. But I mean, look, I'm just changing, I'm saving, and then everything's updating. And that really has beautiful effects. Here I've got a function that defines a little polynomial. If I change this, so I change x to the 5 to x to the 4, the, the rendered math will update. But here we also have a plot. So here's a plot object that took f and some options and rendered as this beautiful, I think, draggable function representation. So if I change this to 5, that should live update. If I change it to 8, we should get, whoa, a little funkier shape. Let's go back to what we had. And here below, I've got a more complex graph, which is saying take f, also plot the derivative of f, and then the second derivative too. Please plot that. So if I'm looking here and I change this to 8, all these things recalculate. So the derivatives are done on the server. Code is sent over the wire. I was just laughing because it's so great. Then the browser goes ahead and plots these things. But it just feels like you're writing down things you want to see and the system's doing it. A lot of the difficulty of this was when I write down something like the derivative of f. Like that, we don't know how to send that by default over the wire to go in the browser. But we can use Emmy behind the scenes to just make that work without you ever having to know about it, which is so great. You can build these interactive scenes where you're dragging points around. And what's so nice about this, I haven't done it in this essay, it's a little overkill, but I can take the positions of this point, I can have that affect things going on in other animations. So you can really tie together these beautiful micro worlds. And this is all just writing, like, look, we just go back to text, it's no problem. It's such a nice, supple environment. Also, anyway, there's a lot more to talk about down the road. So yeah, check this out. This all lives at reality.mentat.org. I hope you'll check it out and go through the effort of getting this environment set up so you can play too.